In this video, we're gonna see how to use standard scores to find percentiles. Once we know the standard score of a data value, the property of the normal distribution allows us to find its percentile in the distribution. This is usually done with the standard score table. So basically, that's the main reason why you standardize a normal distribution. No matter what your scenario is, you standardize it by finding the z-scores, and you can look up in the table what percentage or what proportion of the area is under the curve to the left of the z-score. Okay, so this table right here, this is available in all the statistics books, and you can find them online. This is just part of the table. Usually the tables include values from -4 to 0, and there's another part that includes all the values for 0 to +4. So basically, this is the area under the normal distribution curve to the left of the standard score. Okay, so if you're looking for a score of z is 0, that will correspond to the mean, and that tells you 50. That means 50% of the data values are to the left of the mean. Let's find -1. A standard score of -1 means one standard deviation below the mean. So that this table tells you that 15.87% of the data is to the left of one standard deviation below the mean. So notice this also gives you the percentile, because -1 is the value where 15.87% of the data is below that value. Then this tells you that the standard score of -1 is also the 16th percentile, or the 15.87 percentile. Let's look at an example. Cholesterol levels in men 18 to 24 years of age are normally distributed with a mean of 178 and a standard deviation of 41. What is the percentile for a 20-year-old man with a cholesterol level of 190? Okay, so what we need to do here is find the z-score and then look it up in the table, and the percentage that corresponds to it will be the same as the percentile, because the percentage that corresponds to it will tell you what percent of the data is less than that z-score, is to the left of that z-score. So remember, the formula for z-score is to find the standard score. We subtract the data level that we're given, 190, minus the mean of 178, and then after we subtract that, we divide by the standard deviation of 41, and we get 0.29. Now if we look at the table, 0.29, we find this in the table, close to, I find 0.30. In a full standard normal distribution table, you will find 0.29, but this is an abbreviated one. So for a standard score of 0.3, you see that the percentage, there's 61.79% of the data that are below that score. So you can say that the percentile, this corresponds to about the 61st percentile. Okay, so this is how we use standard scores to find percentiles for certain situations. Now, part B of this question: what cholesterol level corresponds to the 90th percentile, the level at which the treatment is necessary? So now we need to use the table to find the closest value to 90%. So if we look at the table, here's the closest value to 90% is 90.32, and that corresponds to a standard score of 1.3. So now we kind of go backwards, use the standard score of 1.3 to find the actual level. Okay, so The 90th percentile is about 1.3 standard deviations above the mean. So we have, going backwards with that formula, we take the mean and we add the z-score times the standard deviation, and we get that corresponds to an actual level of a cholesterol level of about 231. So that corresponds to the 90th percentile, and we know that you're there. You probably need some treatment to reduce that cholesterol level.